All right, but as I said, anytime I'm absent, you always turn in a note sheet, so hopefully that's not a surprise to you. That should be like an easy 10 classwork points. And then you also have practices. Really, all your practices should be done through lesson 9. So they're not very long this unit, the practices, we kept them short and sweet and to the point. So if you're not understanding the answer, so I know most of them, it's like 2 options, right? And then once you get one of them wrong, you just go back and change it. But if you're not understanding, then you need to make sure that you're asking. Including this week, there's like 3 total weeks, and then like the 2 days of finals that following week. So today is one of the last 3 dates that there is tutoring to retake a test. And then of course there's Saturday Academy this weekend and next weekend on Saturday. I've sent this information to you and your parents, so if you need a list or something, it's been sent. The most updated list is always in Schoology, and I'll show it to you right now. I mean, I don't have the tutoring dates or Saturday Academy dates on here, but for me, tutoring's every Wednesday, Saturday Academy's on Saturdays. 2 Saturdays left. Questions on end of the year stuff? All right, we're really almost done with unit 4. So we should be testing for unit 4 Thursday next week. And that means, you know, all your binder stuff from unit 4 should be up to date. If you're absent, you are responsible for the lessons. Like there's just no way around it. I can't pass you for your 9th grade math if you're not like learning the material. So if you are absent, you just end up making it up on your own. Luckily, I record everything, so hopefully that's not too like daunting of a task. You don't necessarily need the note sheets that I provide. If you ask for them, I will give them to you. But you can take notes on your own paper and it still counts as your binder text. So just, again, the end is near, so make sure like we're finishing strong. Questions on deadlines, things like that. Okay, you do have a quiz this Friday over what we've learned in unit 4 so far. So keep that in mind too. We're on lesson 10 today. That goal is to find all possible inputs and outputs for a function. The lesson is called domain and range, so you'll learn what that means and how to identify it in a function. And then of course, what a reasonable domain and range would be. I'm recording right now. It'll be linked in here. I do plan on having another link for how I taught domain and range last year, if you want to see that. And the puzzle piece will be lesson 10. My first hour had time, but they kind of didn't use it as effectively. So I do check to see like who's even opened the assignment, who's working, who's just sitting on their phone and not working. Because if you're using your electronics and you're not working, like when I give you that independent time and I say that it's okay to like listen to music or whatever, the condition is you have to be working. So if you're not, then that would be a violation. You get a purple pass if you're not working and using your electronics. Okay, but moving on. So we have a warm up. It's not on your paper. So just look up at the screen and follow along. Previously, we saw a situation where the total number of times a dog barked was a function of time in seconds after the owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. You first quietly will think of the answer to these questions. The first one is, could each value be an input of the function? What are inputs? X's. Other things that we use to describe inputs?
Function.
Yeah, but like, what type of variable is it? Independent or dependent? Independent. So Think about if these numbers down here would represent the independent variable in this situation. And then same question, but then for the outputs. So the outputs are your what of a function? The y's or your dependent variable. So think to yourself quietly. I'll let you know when to share with your groups. All right, so table 3. For number 1, could each value be an input of this function? Yes or no? Don't answer for first. Yeah, table 3. No. Okay, which one would not be possible? Why do you think 84.5? First, let me ask a different group. Table 6. What would the input be in this situation? Would it be the number of barks or the number of seconds? Okay, good. So let's kind of jot that down. So inputs represent number of seconds. How you know? Well, time is usually independent. That's usually your input. What else? How else do you know? Nothing really changes time, right? So that's why time is independent. That's why it's your input. So back to table 3. Are we allowed to have a fraction of a second? Yeah, so do you still think 84.5? Okay. Let me ask a different group. Table 8. So we already concluded this one is possible. Do you think that 15 and 300 are both possible inputs for this? Okay, yes, we could have 15 seconds. It is possible to have 300 seconds. Anyone think no? Who thought that one of these could be impossible? Okay, Brian, which one? And why the 300? Okay, so going back to the situation, it says that the owner returned less than 3 minutes after he left. So time was seconds after the owner left, had the dog to the post, and blah, blah, blah. So how many seconds are in 3 minutes? 180. So anything that is really over 180 would be possible or impossible? Impossible. So is 15 possible? But not the 300 because that's too long. So the answer to this is no, because this is more than 3 minutes. Okay, questions on that? The other two are possible, but not the 300. All right, now table 2. Answer number 2. Could each value be an output of the function? All right, which one do you think could not be? And why 84.5? Okay, so we're establishing that outputs represent number of barks. And Jalen said, no, you can't have half a bark. Can you? No. Right, you can't. So that's why that one is not possible. Is it possible to have the 15 barks? Is it possible to have the 300 barks? Yeah, maybe it's barking a ton. Maybe it's barking so much that it's barking like multiple times in 1 second. So those are both possible. Questions on this warm-up? All right, so I also like this warm-up because it gives you more practice with identifying your inputs and outputs for like a real world situation when it doesn't directly tell you. We're gonna do a card sort activity. I know I saw a couple groups that already had a stack of the green cards on your table. If you don't, send your reporter to come get a stack from back here. Who was sitting closest to the door? There are multiple situations. We're just going to start with situation one after I read it to you. And what you will decide with your group is whether each number is a possible input for the function that is described. So you'll have two piles. You'll have possible inputs and impossible inputs. And you'll record your information on your paper. So everyone, don't be a hog, don't be a log, and everyone's still responsible for taking their own notes. And we'll review, of course, after a few minutes. But here's the first situation. The area of a square in square centimeters is a function of its side length s in centimeters. The equation a of s equals s squared defines this function. So figure out in your groups what is my input representing, and then determine out of the numbers you're given which are possible, which are impossible. Questions on what we're doing? Okay. The reporter will be the same person for this activity from before, and then we'll switch it the next activity. Maybe. Depends on the criteria that I pick. All right, so possible inputs. I just want you to give me one of them if I call your table. So table 4, what's a possible input from the list? 9. All right, 9. Class, if you disagree with any of these, feel free to chime in, but not disrespectfully at all. So 9, anyone disagree with that? All right, then table 5, give me one possible input. All right, that is correct. Table 6. 4, there's a lot of side chatter going on. I don't want your side chatter in my recording. Although it would be great to show your parents, you know, but it's fine. Just stop talking. Landon, I still hear you. Okay, so again, let's just kind of keep it moving. If you disagree though, feel free to chime in, but otherwise, like, there's just too much else going on. So good. So far, we're on a good track. Table 7, give me a possible input. 72. Table 8. 6.8. Table 1. Oh, no. 3/5. Table 2. 0.8. Table 3. So the 6.8 we already have. Do you think that any more need to be added to the possible inputs that we have up here? No. Just table 3 right now. Okay. Anyone disagree with that? Does anyone think we need to add more to the possible input list? Speak now or forever hold your peace. 25/4. Let's see. There's 2 more. that are possible inputs on my list that you guys don't have? Which one? 0.001 and one more. 0. That means that the impossible inputs must be what? And now if you're confused, what you needed to be able to identify is what your input represents in this situation. What does your input represent? Yeah, in this situation, for number 1, what did the input represent? A side lane, which is also X, yes. But side lane is what your input should be representing. So look at the possible inputs again. Is it possible to have side lanes that are decimals, that are positive numbers, that are even fractions? Because can't fractions be converted to decimals? Yeah. Why can't we have a negative side lane? Can you ever like measure something and get a negative? No, not for length at least. So yeah, that's why it's just those two that were impossible. I'm going to kind of take a moment to go over some vocabulary with you because part of the goal for today is to not only know like what's reasonable versus unreasonable, but to tie it to these vocabulary words. So first is domain. Sorry, I need to scroll down. All right, so this isn't written on your note sheet at all, but feel free to jot the definition down. It's a pretty short definition. The domain is a set of all possible input values. What else do we call inputs? All of the x's, all of the independent variables. So in short terms, I just say domain is all the x's. That's what I would probably write on. So if that's domain, guess what the range is going to be? All of the y's of a function. It's all the possible output values. So going back to my example that we just did together. In the blue, would that be the possible domain or the possible range? Possible domain, because again, we're talking about the input. So maybe jot that down next to it, possible domain. Try that vocabulary. Now, possible, we can switch out with the word reasonable, because a lot of the times on tests, it'll say what's a reasonable domain for this function. You could say all positive numbers in that case, or something along that line. We didn't talk about the outputs in this problem. It didn't ask about it, but what would the outputs represent in this one? It would be my range, but just in this problem, it would be my area. All right, the area depends on my side links, doesn't it? So it didn't ask about the outputs, but the outputs kind of have something similar for their reasonable ranges. Wouldn't it also be all positive numbers? Should be. All right, moving to the next one. So situation 2, you'll do the same activity, but now your possibles and your impossibles might be different now, but you're looking at the same set of numbers. Just this time we have a tennis camp charges $40 per student for a full day camp. The camp runs only if at least 5 students sign up, and it limits the enrollment to 16 campers a day. The amount of revenue in dollars that the tennis camp collects is a function of the number of students that enroll. They give you an equation here that represents it. You guys will be finding now the possible and impossible inputs using the same parts. So since you already did that with a different activity, I'll give you a little less time. So I'll give you like 3 minutes. What's an easy way to know what the input is when it's written in function notation? Where do I look? What's the input? The number of students. What variable represents the number of students? N. So that is in the parentheses, as you can see, and the input is usually in the parentheses. So if they give you an equation, that's an easy way to tell what the input is. And usually they define the variable somewhere in the column. If they don't, well, you just have to see what's independent and what's dependent. So independent would be the number of students. Dependent would be what? So my output would be what? Class? Amount of money made. All right, they summarize it as revenue, but yeah, amount of money that they made. But it's asking about the inputs. I just want to make sure that's clear before I start out the table. So table 8, give me one possible input for this situation from your list. 9. Anyone disagree with that? If you do at any point, just chime in. All right, table 1, give me another possible input. Do you think that there's no more possible inputs? Okay, give me another one of them. 1. 15. All right, table 2, any other possible inputs? 4. All right, 4. Anyone disagree with that, class?
Yeah.
Why do you disagree with that? All right, so it is possible to have 4 students, right? But not for this camp. This camp wants at least 5 students to sign up. So this 4 is technically impossible because of that constraint. Okay. So anything that is smaller than 4 is possible or impossible? Impossible. So just tell me the ones on our list that are smaller than 4. 0 is smaller than 4. So that would be impossible. What else, class? 0.001 is smaller than 4. Anything else? -3. 0.8. Sorry, what was that? -18 is smaller than 4. 3/5 is smaller than 4. Oops, that's 3/4. 3/5 is smaller than 4. Any others that are smaller than 4? All right, no. Now look at what else we have left that we haven't categorized yet. Could we have 6.8 students register?
No.
Why not? No, that's still, it's a whole person. Even if they are missing something. But yeah, so that would also be impossible. 6.8, any decimals? Anything else that needs to be added to the impossible list? Why 25/4? Good. I don't know if you guys heard that. I'll repeat it. 25/4 would be a decimal, right? And again, we just said we can't have decimals of a student. Anything else that needs to be added to my impossible list? Why 72? Good. It limits the enrollment to 16 campers a day. So if I had to summarize my possible input, it would be anywhere from 5 to 16 people, right? But not decimals, because you can't have decimals of the people, of a person. 6.8, even though that falls between 5 and 16, not reasonable for this given situation. Does that make sense? All right. One more, or yeah, let's do the last one together. Actually, we don't need to do the card sort, I think, because I think you're getting the hang of it. But we have the relationship between temperature in Celsius and temperature in Kelvin can be represented by function K. And it's written in function notation there. C will be for Celsius, K of C will be the temperature in Kelvin. So think quietly, don't shout it out. Think about what the input would be. I'll let you go if you can tell me what the input would be. Celsius or Kelvin? I'll let her do it, guys. Okay, good. How do you know? And it's in the parentheses. All right, go ahead. All right, that's an easy way to tell. Otherwise, kind of just have to see what depends on what. So the Kelvin temperature depends on whatever the temperature in Celsius is, because you're adding 273.15 to it. You'll do that a lot in science. And then if you go to college for science, you'll do your experiments with Kelvin. Just FYI. But that's my input. My output is what then? The temperature in Kelvin. Doesn't ask about the output in this one. Just asks about the possible inputs. Now, are there any on our list that you think could not be possible? Like, is it possible to have positive numbers for a temperature in Celsius? Yeah, can we have decimals for temperature in Celsius? Yeah. Earlier someone said no, but think about like your body temperature. When you take your temperature, it's usually a decimal on the thermometer. Your thermometer is usually Fahrenheit, but Celsius is similar like that. So yes, you can have decimals. Can you have negative temperatures in Celsius?
Yeah.
Yeah, really cold places would. So are there any values that would not be possible? All right, on our list, no. So possible inputs would be all values. Impossible inputs would then be what? None of them are impossible, so I'll put no value. You just have to reason with, can it be a decimal? Can it be a fraction? Can it be negative, positive? Are there limits set in the situation? That's how you understand your possible inputs, or in other words, your reasonable domains. Questions on the first activity? All right, now let's talk about the outputs real quick. So we talked about area, so think back to that situation. Here's that formula again. When we talked about the formula, I'm trying to tell you without giving you the answer. What did we say the output is? Area or side length? Area. We described the input as any number greater or equal to 0. How would you describe the set of possible output values? Would you also say that it can be greater than or equal to 0? For the area? Can my output be negative numbers? No. Can it be decimals, fractions? So then I would also describe it as any number greater or equal to 0. And that's what's shown on this graph. What type of graph is this called? If you guys remember from before break. It is nonlinear, but other words that we've used to describe it. Is it discrete or continuous? Continuous, because all the points are connected, because it can be decimals and things like that, because usually they're making them connected. Now, if you look at this situation, this is for the number of campers. We're going to choose which graph is correct. One of them is wrong. So do you think it's the continuous graph that is correct or the discrete one? Now, think that to yourself. Don't say it out loud. All right. Raise your hand if you think it should be the continuous graph. Raise your hand if you think it should be the discrete graph. I just see way more hands. You'd all be raising your hand. But yes, it should be the discrete graph. And you know, because can you have a fraction of a person? No. So that is why. The money, I suppose, could sometimes be continuous, but if my input is people, then it's either this amount or this amount or this amount, whatever the number is times 40. So you really shouldn't have anything between these dots. And look, it starts at 5 and ends at 16 for the inputs. And that's really all I want to show you for the outputs. So questions on that? All right, then you have a puzzle piece. It is lesson 10 in Schoology. Really, all of them should be done though through 9. So make sure that's done too. I'm going to keep an eye out to make sure that you're working. So if you have your headphones in, things like that, and you're not working, it is a purple pass. Yes, please. All right, if one person from each group